Hello and welcome to another video. In previous videos I showed you what is a graph rack, what is a light rack, when you should choose each of them, and how to implement them. Also I showed you how to develop a supervised agentic rack using LangGraph and use Neo4j knowledge graph database as your knowledge base for your agents. In this video, you're going to learn about an underrated framework for developing AI agents named Semantic Kernel. If you know what is Semantic Kernel and you know what is the difference between Semantic Kernel and LangGraph, you can just go directly to the implementation section. Otherwise, stay with me and trust me, this is gonna be interesting. And for those who don't know me, my name is Humayun and I have more than 8 years of industrial experience. I opened this channel to help you to be updated with recent trends in technology and show you how to implement them efficiently. And of course, your like and subscribe give me motivation to make more videos like this for you guys. So what is Semantic Kernel? Semantic Kernel is a lightweight open source development kit developed by Microsoft that lets you easily build AI agents and integrate the latest AI models into your C#, Python, or Java code base. It's designed to help you build real-world apps quickly. There are 5 main components exist in Semantic Kernel. The central hub that manages everything, it ensures all part works seamlessly, is kernel. If I want to make an example about kernel, it's like a node in the LangGraph. If you have experience with LangGraph or you saw my previous videos, you understand that a node in the LangGraph is the center of managing everything. To call the tools, to call the prompt, AI models, and then manage the process to reach to the final response and return it to the user. The second important component is plugin. Plugin is the tool that your agent can use to perform actions based on the user's request. The third component is the planner. Planner is an intelligent component that creates a step-by-step plan to achieve a given goal by orchestrating available plugins or tools. Same as LangGraph, Semantic Kernel has memory system. Memory system component in Semantic Kernel is a system that allows the AI to remember and retrieve information using vector embedding. Unlike LangGraph that you needed to design this embedding system for your memory, this is already created in Semantic Kernel. Next is AI service connectors. This component allows you to connect your agent to different LLMs. The last component is filters. Filters are mechanisms that allow custom actions to be performed before and after specific events, like function calls or prompt rendering. They help in tasks like logging or modifying behavior dynamically. Now that we know what is Semantic Kernel and what are the main components of this underrated framework, we need to know when to use this framework. I decided to compare Semantic Kernel and LangGraph based on 4 important criteria that, based on my experience, are really important when it comes to developing an AI agent for your business and you want to push it to the production. The first thing that you should pay attention to is either the framework you're going to use is production ready or not. Yes, you can develop agent with other frameworks, but when you want to push it to the production, there are bugs and problems that comes up, and that shows this framework it's not ready yet for the production. LangGraph built upon the LangChain ecosystem. LangGraph offers a graph-based architecture that allows for precise control over agent workflows. Its design facilitates clear visualization and debugging of complex multi-step tasks. On the other hand, Semantic Kernel developed by Microsoft. Semantic Kernel is tailored for enterprise environment. Since the first day, they tried to build something that is production ready. Semantic Kernel provides a structured planning, plugin, architecture, and seamless integration with Microsoft AI ecosystem, ensuring stability and reliability in production settings. So Semantic Kernel is more suited for enterprise-grade applications requiring a structured workflows and integration with Microsoft's ecosystem. LangGraph excels in scenarios demanding intricate control over agent behavior and workflows. The next thing is scalability. LangGraph is designed for stateful multi-actor applications. Since LangGraph is based on the graph, it allows you to scale your application based on the nodes and the edges between those nodes. And you can perform complex tasks based on the architecture that you design. Semantic Kernel is built in small independent pieces, and it uses thread pool to do multiple tasks at the same time. That means it can handle lots of requests at once without slowing down, because each task runs on its own thread. You can add more machines to your system or instances, and it will keep working smoothly as you grow. So both frameworks are scalable, but Semantic Kernel offers more straightforward scalability for enterprise applications, while LangGraph provides flexibility for complex, dynamic workflows. The next thing is maintenance. LangGraph is like having a detailed roadmap for your AI workflows. Each step in process is represented as a node in a graph, and you can plug into tools like LangSmith to see how data moves from one node to the next. Because you can watch every connection and execution in real time, it's very straightforward to spot where something went wrong and fix it quickly. And this can make the maintenance and debugging easier. Semantic Kernel automatically collects detailed information about everything it does. What function it calls, how long each step takes, and how different parts of system communicate. It follows a standard called OpenTelemetry, which means you can hook it up to a popular monitoring dashboard right away. In a large enterprise environment, this built-in login metrics and tracing, making it simple to keep an eye on the system health and diagnose problems without extra step. And the last one is streaming. LangGraph supports limited streaming through custom implementation or wrappers. Each node must be carefully designed to handle a streamed output. Out of the box, it waits for full LLM response, making token-by-token streaming harder to implement consistently. On the other hand, Semantic Kernel can stream words one by one as they are generated. There is something here I just need to mention. When you are using LangGraph, still there's a possibility that you can stream the response one by one after the tokens are being generated. However, when you are using an output parser for your agent, then it's gonna have some limitations. Because, for example, let's have an example about the JSON output parser. When you are generating the JSON output parser in the LangGraph, the first part of the JSON is being generated, and this is a partially generated JSON data. So you cannot use any function to turn the JSON string to a normal JSON function and call the keys inside it. This is a limitation that Semantic Kernel can overcome it. If you ask me if Semantic Kernel is better or LangGraph, first of all, I'm going to tell you that what is the problem of your project. But something that is possible here to do is using them together. Use the power of multi-agent system design of the LangGraph and use the Semantic Kernel as a node in this graph. In this way, not only you can have a system that is a multi-agent system and it can talk to each other and it's really reliable, you can track everything inside it and you can stream it as they are being generated. Now that you know what is Semantic Kernel and what are the main components of this framework, let's build a simple AI agent using this framework and connect the Neo4j knowledge graph as a plugin or tool to our agent. Just remember, I'm not going to explain the process of creating knowledge graph in this video because I already covered everything in the video. I'm putting the link up here. First of all, we need to define our config files. In our config, we have 3 files. One of them is the LLM that we are going to define the LLM that we are using. The second one is 𝗃𝗄𝗏 config that we define the connection to the 𝗃𝗄𝗏 knowledge graph. And the third one is this file allows us to define the function that we retrieve information from our knowledge graph using the vector similarity search. For the LLM, this is the code that we are using in order to call the model, the GPT-4.1 Nano. And I'm going to call this function through the Semantic Kernel library. I already installed it, but if you want to install it, this is the code that you can use. The next thing we are going to write is the connection to the 𝗃𝗄𝗏. Just remember that I already created my instance in the 𝗃𝗄𝗏 and I defined the username and password in the .env. However, you should do it by yourself if you want to have this connection to the 𝗃𝗄𝗏. And finally, our query vector rag. I'm not explaining it here because I already covered everything in the other video I mentioned earlier for developing a graph rag. Now that we have all of our parts for the config, we're going to define the plugins, which are the tools our function is going to use. These tools is the connection to the knowledge graph. The query will come. The agent will use this tool using that query and pass it to the knowledge graph, retrieve the response, and return the answer to the user in a very structured and clean format. And this is our tool, our plugin. In my database, I'm using the Napoleon history. That's why I call this class like this. And let's see what's happening inside this function, inside this class, and the method of the getVectorResponse. So here, the plugin gets a question from user using kernel argument. This argument is being fetched by the get function that you can see here. And then we validate the question. We validate that this is not an empty string and it's an actual question. And remember that for your project, you can design any kind of validation that you want. This is a very simple validation step. After validation, we will call our query vector rag, the function that had access to the 𝗃𝗄𝗏 knowledge graph, and it can retrieve the similar vectors based on the question that we're giving to it. If nothing is found, we handle that too. And finally, the top result will be returned to the agent as a string. Now that we have the tool, we need the kernel. This is the function for our kernel. And let's see what's happening inside this function. This will initialize a new kernel for our semantic kernel. Then we add a plugin to our kernel, which in our case is the Napoleon plugin already we defined in this file. And the next thing is the service, which is the LLM. And finally, we initialize the chat history and the system prompt we are going to use. And finally, we execute our kernel. Now that we have everything, we need to create the main file to run our agent. And this is the main function. First of all, we define the kernel. All 3 variables that we already defined in our kernel file, we initialize it here, and we build our kernel. Then we define a while loop that we enter our message, and if we want to quit our agent, we just press the Q. Also, in order to add the messages to the context, we use this function to add the user input to the message history. And then we just stream our response as being generated token by token by the LLM. And when the AI message is generated completely, we just add the full response to the chat history. Let's run our agent now. Perfect. Even though it's not accurate enough, it's a simple agent. We need to work more on the prompt in order to increase the accuracy, but I think it's working properly for now. And this is how you can develop a simple AI agent using Semantic Kernel framework. If this video was useful for you, I appreciate if you like it and share it with your friends. Let me know if you have any questions. I will answer to all of them. And thanks for watching this video. See you in the next one, guys.